Hey guys, welcome to this tutorial video. Today we are going to talk about another design pattern. This time we will talk about the chain of responsibility design pattern. First, as usual, I'm gonna give you a quick introduction into the pattern itself, where I tell you a few things about it and to what design pattern family it belongs to. After that we will go over the advantages and disadvantages of using this design pattern. When we are through with all of that, we will go ahead and look at a use case for using this pattern. Then we will have a quick look at an example class diagram where this design pattern has been implemented and just briefly look at the main traits we can identify there. Finally, we will jump into a coding session in Visual Studio 2019 where we'll code our own small demo application implementing the chain of responsibility design pattern. So let's jump right in. Alright, first a small introduction into the topic. The chain of responsibility design pattern belongs to the behavioral design patterns. Here is a quick explanation as to what exactly that means. In software engineering, behavioral design patterns are design patterns that identify common communication patterns among objects. By doing so, these patterns increase flexibility in carrying out communication. What this design pattern basically does is making multiple objects form a chain of receivers for any request that gets sent towards them. By applying this design pattern, sender and receiver of the request can be decoupled quite easily, and objects decide on runtime who exactly will be processing the request. Okay, now we will talk about the advantages and the disadvantages of using the chain of responsibility design pattern. Let's start off with the advantages. The first thing that we reach by using this pattern is decoupling sender and receiver. And decoupling our application is always a good thing. Then, apart from that, this design pattern will simplify our objects, since every object only needs to know who is next in line instead of knowing the entire chain of responsibility. And finally, this design pattern makes it possible to dynamically add or remove responsibilities by, for example, changing the order of the chain. Alright, now let's talk about the disadvantages. There's not really much to say here except that by using this design pattern, it will be harder to actually observe what is happening at runtime, which in return will of course also make debugging harder. Excellent. Now let's continue by briefly looking at a use case for this design pattern. A use case for the chain of responsibility design pattern could look a little like this. The email services of a company could be implementing the design pattern in order to filter out emails that they receive. The first handler in that chain would be the spam handler, which would either identify it as spam or pass it to the next handler. This could, for example, be a ticket handler, which will check if the email will be used to create a ticket for the company to work on. This chain would go on until one of the handlers in the chain would be able to process the mail. Alright, now let's have a look at this class diagram. What we can see here is a simple example of how the chain of responsibility design pattern is implemented with different loggers. The key thing to look at here though is the abstract logger class. This is an abstract class which contains functionality for loggers and for the chain of responsibility design pattern. For now, we will only look at the stuff that is important for the design pattern. First thing is that the class contains an next logger property, which is also of type abstract logger. With that property, every handler in the chain can always know who the next handler in line is. And of course, there has to be a method to set this next logger, which is the setNextLogger method. Then, finally, there is the logMessage method, which is basically the method in which the handler will try to process the request, and if it is not able to, it will pass it to the next handler by calling that exact method from the next logger property. And that's basically everything concerning this design pattern, which we can see on this diagram. Okay, let's finally get into the coding part. First we'll create a new project, console application, and we'll call it something like chain of responsibility demo. Alright, we'll go ahead and create this project. And when this is ready, we will jump right in and create a new class. This class will be called handler, because this will be the abstract class from which all other concrete handlers will inherit from. Public abstract class handler, like this. Then we'll go ahead and create the protected property, which we will call successor. This will be the next one in line, basically. This is who the handler will call when he himself cannot process the request, so that the chain of responsibility can go on and the next handler can try to process the request. After this, we will create a method called setSuccessor, which will take in a handler, of course. And this is the function where the successor is being set, basically, so that we can form a chain of responsibility. Like this. Sorry, yeah, okay. And then the last thing missing, of course, is the handler request method, which will not be implemented here because every concrete handler will have to do this in the way that it wants to. This will take in a request like this, and that's basically it. That's the entire handler class from which all the other can inherit. So we'll go ahead and create our first concrete handler. And we will just call it concrete handler 1. Like this. Add. Alright. So this class will of course be public. Wait, like this. And it will inherit the handler class. Like this. Alright. So now the thing that it's missing here is of course the handle request method. So we will need to override that because that's the only thing that the concrete handler needs to do. Public override void handle request. That's also being shown here. Exactly. All right. So to keep it simple, we will just do it with a simple if statement. If request equals to or request equals 4, then we will basically just do a console.writeLine. This will be the processing part that we were going to simulate. Then this get type name handled request. Okay. So this will just help us later to see which handler actually handled the request. Then after this comes the interesting part, else if successor is not null. So if there is a next one in line basically, then pass the request over to him. Like this. And then what you can do of course is something like else and then do whatever you want to do here. When no one in the chain of responsibility is next and the request still could not be handled, then you can do something here, whatever you want. We'll just say chain of responsibility is over. Something like this. You would of course do something else in a real world application. This is just to make it visual. Alright, so we got our first concrete handler. We'll go ahead and copy this and create another one so we can have a little chain. Concrete handler 2, add, and then we can just go ahead and basically paste this in here and change the name. And of course this also, because this will be handling different requests. But apart from that, this is already finished. We have 2 concrete handlers that can be chained together. You can of course do this with even more, like up to whatever you need, but we will keep it simple with 2 just to understand the idea behind it. So now we'll go into program and we can go ahead and create a handler, but we will say new concrete handler 1. And then we will do the same thing with the next line, but we will create a concrete handler 2. Alright, and now we can set the successor. Successor of the first set successor will of course be the concrete handler 2. Now we have got no successor for the second concrete handler, but in a real world example, of course, there would be even more. This is just to show how it works. All right, now we can go ahead and do something like this. This is our requests, an array of integers 2, 4, no, or 2, 3, 4, 6, and 8. So these are our incoming requests. So we need to loop. We will go like this, requests. For each request in requests, we will go ahead and let the first handler in the chain of responsibility handle the request. And we'll throw in a little console.read key. And then we can build the application and we can see what happens when we run it. As you can see, first request goes in, concrete handler 1 is able to handle it. Then second request goes in, concrete handler 1 was not able to handle it, so it passed it over to concrete handler 2, who was able to handle it. Same again here, concrete handler 1 was able to handle it, and then again it had to give it over to the second concrete handler. And then for the last request 8, which was not handled anywhere, it gave us this chain of responsibilities over, which of course in real life example would be something else. All right, and that's basically it for this video. This was the chain of responsibility design pattern. I hope you enjoyed it. Stay tuned for more.